Okay, so for warm-up, we got a pretty good review of what we've done this week, I guess. Number 1 is from Thursday, 2 and 3 are from Friday. Okay, so number 1 is all about z-scores. Okay, if I've never given you this statement right here, if I'm ever telling you how many standard deviations away from the mean that we are, that's all z-scores. Okay, so biology test, you got a mean of 78, standard deviation of 4. Brandon was 2.2 standard deviations below the average. Okay, what did he make on the test? So what value am I asking for here? Well, a value. But how do I set up an equation to solve for that? Like using the z-score. It's like the only formula you got to memorize for this test. What does it say? Z-score. Remember what I boxed here, that is what my z-score is. It tells me how many standard deviations away from the mean I am. I'm 2.2 away. Is it positive or negative? Negative. Below means negative, so I got negative 2.2 equals. And then the value, which is what I'm looking for, subtract your mean, 78, divide by your standard deviation, 4. And then just solve. Some people just do this like kind of logically in their head, and they tell me they do, but what they're really doing is this formula. Okay? They multiply it by 4 and then add 78. Okay? So multiply by 4 and subtract. Okay? So what's that? Negative 8.8 equals 78, or sorry, x minus 78. Add 78 to both sides. What's 78 plus negative 8.8? I think it's 60.2? No, 69.2? Is that right? So if you score a 69.2, you are 2.2 standard deviations below the mean, which really is kind of bad. You got far below the mean, right? Very low percentage there. What do you think? Not bad? All right, and then number 2 and number 3, if I'm talking about like values or percentages, that kind of stuff, like in number 2, number 3, that was all done in the calculator. So your homework was on. It was all done in inverse norm or normal CDF. Okay, so look at number 2. Look at the keyword here. It says Sarah wants to get into a university that only accepts students who score in the top 25% of all SAT takers. Okay? Well, they're normally distributed. We got our mean and our standard deviation. That's always the same crap it's going to tell you. What score is Sarah going to need to make to get to university? What operation in my calculator am I going to have to do to solve this? Close the other one. Inverse norm. Inverse norm is what you use whenever you are given the percentage or the area under the curve and asked to find the corresponding value. Okay? So if you go to this, remember, just to refresh yourself, it's second, go to vars, and I think it's number 3 for this one. That's how you do it in the calculator. It's going to give you a menu with 3 things, remember. Area, your mean, and your sigma. What's the area that I got to plug into this problem? 0.75. 75. Because if I say top 25%, remember, that's going to curve. Remember on my curve, that's like over here somewhere. There's your top 25%. Our calculator's dumb. It only gives the value corresponding to the left area. And remember, that is the same thing as having 0.75 here. So, the calculator, the area is 0.75. What's that little U thing mean? Mean. Yeah. In this case, it's 1800. And then 140 for the standard deviation. That's pretty good. What'd you get? Can I do it? Yeah, we'll just say that 1894 for sure. You got to score an 1894 to be in the top 25%. Some colleges are strict that way. Some colleges require a certain score on their SAT or that other thing you have to take in order to get the college. AC. Any questions on number 2? Number 3 is the same thing, just working backwards. Since teacher salaries are normally distributed with a mean of 35,000, standard deviation of 2,000, what is the probability of having a salary of at most 33,000? So here it's the reverse. I'm giving you the value. I just want to know the corresponding percent. Okay? So what's the operation that we use in our calculator? Yeah, normal CDF. Which is the same menu as inverse norms, the second bar, and option number 2, I believe. And in this menu, you're going to have 4 things, right? You're going to have your lower, your upper, your mean again, and your standard deviation. Okay. Well, let's think about that. Here's my normal distribution curve with 33,000 as my mean, or 35,000 as my mean. 33,000 is like right here. Is that going to be shaded to the left or to the right of that line? To the left, right? If I say at most, the very most I'm making is 33,000, that's my upper. Everything to the left. Okay, so that should be a pretty small percent. All right, but knowing that, what's my lower value going to be in my calculator? Negative a bajillion, right? Yeah, it's negative because we're going to the left, but make it really, really small. You could put 0 or negative a bajillion. Okay. What about my upper? How far right am I going? Yeah, 33,000. All right, the mean and standard deviation is always given. It's 35,000 and 2,000. All right. I've got the calculator. What'd you get? 15.94 or something. 94%. Sure. Pretty cool. Questions on that? And did anybody notice also that 33,000? Yes. Absolutely, right? So here, he noticed like that 33,000 is actually 1 standard deviation below the mean. It's an exact standard deviation away from the mean. So technically, we could use the empirical rule. And I think if you use the empirical rule, it's 16%. So the calculator is going to give us a number very, very close to what the empirical rule gives us. It's just the calculator is not going to be exactly 100% because it's just guessing. So it's going to be really close. Either one, you would have got the right answer. I'll accept it. I think there's like a question on the test, but you can pretty much decide between the two. Either one's fine. But good. Did you do that using empirical rule? Anybody else do it using empirical rule? Good observation. Any questions? Yeah. Oh, camera, I'll check a question. Any questions on the warm-up or the homework? Okay, last lesson. First part, it's a 2-parter. So we got the first part that's all about stats, vocab, and really, I mean, I got some examples to go along with this, but I really don't think we need to because on the test, it's just all matching. Just understanding what the definition is and what it means. It's really about it. There's no math with it. So if you want to try the example in the back later, you can. The notes will be online. It's up to you. All right. But up to this point, we've talked about all the ways that we study stats, all the ways that we can take a bunch of numbers and describe its shape, spread, center, and make assumptions based on that, all that good stuff. But really, a huge part of statistics is how the heck do we get those numbers in the first place? It turns out it's not as easy as you would expect to get those numbers. Okay, it's actually very difficult. That is a whole job in itself, is getting that data for people to study. It's part of being a statistician. So that's kind of what we're talking about today, is how we get the data that we can study. First things first, you've heard these words I'm sure before, but population, that's all the members in a set that I'm looking at. We've used the example in the past of like, in America, all the guys, the adult males with their heights. That's something that we can study. But the thing is like there's a crap ton of people in America, okay? It's impossible to literally study every single adult male's height and make assumptions based on that. So what we got to do instead is we got to find a part of the population called a sample, okay? We got to get a sample, and the goal of getting that sample is to find a sample that is a fair and equal representation of everybody in the population. It turns out to be extremely difficult to do, especially if we have a really big population. A lot of times we introduce bias into our sample. Okay? And the goal is to eliminate bias. Bias is the results that are not likely representative of the population, caused when there is an over-representation an underrepresentation, or an error introduced in the study method. Okay, so like an example, like talking about the adult male heights. Like say I decide to go to like an NBA team to get my sample of adult males. Well, that would probably be an overrepresentation. It doesn't describe us as a population. Or the reverse, I could go to a preschool. No, well, those aren't adult males. Jockey, that's a good one. Yeah, jockeys. Those are really short people that have to ride the little horsies. Okay, I'm gonna stay away from that word, but you know, jockeys. Yeah, that works. That's an underrepresentation, right? That doesn't really give us something good. Yeah. So, or an error on how we study them, but mostly about how we gather the information is where the bias comes in. So, anyway, does that make sense? Bias. Y'all heard of bias before? I'm sure. Okay. All right. The first part of the definitions I want to look at is all the different types of samples that we can get, all the ways that we can gather a group of people from a population. Okay? There's more than this, but this is the main ones. All right, the first one is convenience sample. Literally like it sounds, members chosen are conveniently and readily available. Meaning I'm doing literally no work. I'm just like walking into the classroom, walking into a grocery store and just yelling, "Hey, I need to study y'all." I mean, that's really not it. Okay? Do you think that a convenience sample would or would not have bias? What? Depending on that, maybe. And depending on the question, I guess the answer to all this could be it depends. But for the most part, I would say that there's bias here. Okay, I mean, think about it. Like, if I go into, like, Mrs. Better's calculus class, and I'm like, "Hey, how do y'all feel about school?" They're probably going to give me a biased answer in comparison to, like, maybe going to, like, a freshman, like, regular math class, okay, like a first period math class. They're going to give me a very different answer. And it's not a good representation of how everybody in school feels about school. Thank you. What about, like, a voluntary response sample? Again, just like it sounds, members of the population have volunteered. The best example that I come up with is actually on the back of your paper. It's like being like a radio talk show host, and he's asking people to call in about their views on like gun control laws. Okay, like, do you think that would be biased or not biased? Yeah, it's probably gonna be a little biased. I mean, let's think about it, especially if that radio station's like a country radio station. Everybody calls in like, "Yeah, I want some guns." Yeah, like, I mean, you know, that's going to be a little biased in one direction. Okay, you know? Yeah. Most of the time, if you're not putting any effort into getting this sample, there's going to be some bias. There's going to be a certain group of people coming. All right, but the one that we strive for, the one that's really good, is a simple random sample. That's the one that we try to get. Okay. That's where all the members are equally likely to be chosen. Every member of the population has an equal chance of being picked. The best example I can give is like say the population is Hickory Ridge High School, and I take everybody's name and put it to a hat and I draw a name out. Doesn't every single person have an equal chance of being picked? Yeah, everybody has a name in a hat. Everybody's name has an equal chance of being picked. That's a simple random sample. It just turns out it's not as easy as you think of accomplishing, especially if you have a huge population, factors. This can be very, very like costly. It costs a lot of money to do. People always ask me like, why wouldn't you always do that over these first two? Well, if you notice, these first two are very easy to do, very time efficient, and very cost efficient. So sometimes you get away like what you want, you know. So. But these other examples here are all examples of random sample. And the rest of these examples, this one, and this one, you're going to eliminate most of your bias, okay, because it is random. Like look at stratified random sample. The population is divided into groups, which are called strata. Divided into groups based on a common characteristic, and then of those groups you take a simple random sample. Another good example, like Hickory Ridge High School is the population. I divide y'all up by grade. Like you got the freshmen, sophomores, the juniors, and the seniors. And I take an equal simple random sample from each. See how that is a stratified random sample? They all have a common characteristic. It's your age or your grade. That's like what you would use if you want to have an equal representation of each type of characteristic. In this case, age. Sometimes you can break it up into boys and girls and have equal representation of that. Anyway, that's good if you're trying to study the different effects of like certain characteristics. Age, gender, race. Any questions on that? All right. What happens is students mix that one up all the time with this last one here. I'm going to skip down to this one, cluster sample, because it sounds kind of similar, but it's kind of different. It says the population is divided into groups again, but not based on any common characteristic. Not based on any common characteristic. And then you're going to take random clusters as your sample. So basically what I mean is your groups are pretty much the same type of demographic as your population. They're the same thing but on a smaller scale. There's no common characteristic. Example. We are evacuated into the stadium, the entire school, and my population is Hickory Ridge High School. If I take different clusters of groups based off of the section that you're sitting in, that would be a cluster sample, because that's not based off of any common characteristic other than your location. Okay? It's an equal representation of the school as a whole. It could be every type of person in that cluster. Does that make sense? Well, I guess you tend to sit with people more like yourself, but whatever. All right, and then lastly, the systematic random sample. That one's pretty straightforward. Members are put in a set order, straight line. The first member is chosen randomly, and then every nth number is chosen after that. So, like, I put y'all all in a line. I choose the first person, and then I go every fifth person after that. Systematic random sample. Okay? Questions on those? That's all the ways that you can gather a sample. But then once you gather that sample, how the heck do you study them? How do you get information based off? Well, depending on what you want, there's different methods to be used. Okay? We're going to talk about 4 of them. Okay? All these you've seen before. Different classes, different situations, nothing too new. Like these first 2 you've seen in a science class. Like an observational study. Exactly like it sounds, you're just going to sit there and observe the members in your sample and just watch what happens. Like an example would be you get a sample of a population to study sleeping patterns. So you're just going to sit there and you're going to watch them sleep. That's it. And observe the outcome. Observe what they're doing. They might be restless. Who knows? And there are people that are paid, statisticians that are paid to sit somewhere and watch their samples and make paragraphs about them, write about them. They get paid a crap ton of money. So. Now, the opposite of that would be an experiment. And I'm sure you've done both of these in science, but the sample is divided into 2 groups. One group is given a treatment, the other one is given a placebo. What's a placebo? Yes. Sure. It's something that has no effect on you, just to see if your mind is the one that's controlling you, right? And I don't really need to go over these too much, because when you see these actual examples, they're very specific and obvious. But like with the sleeping one, instead of me just watching it, like I give half of the group a sleeping pill, and then the other half a sugar pill, and see what happens. And the sugar pill might actually keep them up. But, it's always trash, I guess. And the last 2, or this one for sure, you've definitely seen. Survey. Everybody here is taking a survey. You just ask every member in the sample a set of questions. I mean, this is good if you want to know how people feel about stuff, like products, and politics, and their opinions. Usually nobody cares about people's opinions. But it's good for marketing. And then the last one, the definition sounds confusing, but you've seen this before too. A simulation. It's the use of a mathematical model to recreate a situation with a known theoretical probability so that the likelihood of various outcomes can be more accurately estimated. the best thing that I can do, or the best way I can describe the importance of simulation is if you're like have a time restraint. Like if you can't wait, like if you have a sample of like 10 pregnant women, okay, 10 pregnant women, and you want to wait 9 months for them to have their babies. Okay, this is a very simple example, but like you could flip a coin. It has the same theoretical probability of having a baby. It's a 50-50 shot of heads or tails versus a 50-50 shot of being a boy or girl. And you can estimate how many boys you're going to have and how many girls you're going to have. It's a very silly example, but that's what it's like. You also see it with like weather simulations and stuff like that. Nothing too. All right. Questions on that? Questions on sampling or study methods? Any of these definitions? Now, the back side of the paper is all just identification questions. I'll let you try that on your own. And I got a little homework with it you can try. There's nothing too difficult. But for now, I'd like to skip over to the next piece of our lesson, just because. Okay? Questions about anything? So, the next piece is Venn diagrams. It's the last thing we're talking about in statistics. You all know what a Venn diagram is. You've seen it before, but it does come up a lot. I've seen on final and fair questions, so we need to make sure we understand how it's read, what it's used for, all that good stuff. Okay? Venn diagrams are just a good way to show how two different sets or three different sets or however many you have compare to each other. It shows overlap. That's really about it. And for our purpose, it's really helpful for simplifying down very confusing word problems. Okay? Every example that I'm going over today, I found on this website. Okay? And there's a video explanation of every single one of those on there as well. So if we do a problem, or if there's a problem on there we didn't do, if you want to watch it, you can get to that website. Okay? But I'm going to go through a couple. Let's look at this first. It says that we have 150 college freshmen were interviewed. 85 are in a math class, 70 in English class, 50 in both math and English. That can be kind of confusing. I'm asking how many were both in math and English. Only math, only English. Neither math nor English. I just look at the problem can be kind of overwhelming, but a Venn diagram simplifies it down. Okay? So, whenever you start these problems, you always got to ask yourself, how many circles or how many groups am I going to have? 2, right? 2. You have math and English. Okay, we're looking at the students that have taken both math and English. So draw one circle for math, one for English, and you're good. Now, whenever you're filling out Venn diagram problems, it's kind of straightforward with 2, but you're going to be introduced with a third one here in a bit. Always start in the middle and work your way out. Okay, so start with the overlap. How many students took both math and English? 50, yeah. Okay, 50 students took both math and English. All right, now work your way out. So, like, let's look at just math. How many students took only math? How do I figure that out? Huh? Yeah. 85. When it says 85 took math, that means that there's 85 total in the math circle, or 50 of them only took English, or already took English. So the difference between that is 35. Okay? So yeah, don't put 85 there. 35. Same thing with English. So 70 took English, 50 of them took math, so only 20 of them took English. Whole circle, I guess to say. Now, what does that add up to? 35, 50, 20, what does that add up to? 105. Is that every single person in my study? No, I got 150. So there's, 45 students that didn't take either math or English. In a Venn diagram problem, what you really have is a square or a rectangle that represents the entire population. Okay, that represents the entire population. Whatever's not inside the circles just is considered the rest of the population. That 45 represents everybody else. Okay. So now, like once we do this, we can answer all the questions. It says, how many signed up for only a math class? One that's only in the math section, right? 35. Same thing for English. There was only 20. All right, what about C though? Remember this wording. It says how many signed up for math or English? What do I do with that? Do what? Yeah, you add them all up. 35, 50, and 20. 105, right? Yeah, remember OR statements. We talked about Venn diagrams because earlier. OR means that you add up everything in both Venn diagrams. Because those numbers all represent OR, math or English. And then how about neither math nor English? 45. Yeah. Not too bad, right? Makes sense? Let's bump it up a bit. Try this next. 3 circles. Again, that's not too bad. But it says that we have 100 students now. Look at all this information. 28 took PE, 31 took biology, 42 took English, 9 took biology and PE, 10 took PE and English, 6 took biology and English, 4 took all 3 subjects. I'm busy now. Okay. So, that can be overwhelming on its own, but if we have diagrams to split it up, we're good. So look, we have 3 subjects, right? PE, biology, and English. Okay. Where do I start? In the middle. 4 in the middle. There was 4 that took all 3, so 4. Whenever you're doing Venn diagrams, it's 2, 3, 4, 700, start in the middle. Now where do I go? Pieces, yeah, the pairs. You start with the triple, then you go to the pairs, and you keep working your way out. Less and less intersections. Let's work backwards. Let's start with biology and English. It says that 6 people took both biology and English. So what number goes here? 2. Yes, 2. Very good. All right, because biology and English, that's this intersection right here. Okay. 4 of those 6 are also taking PE, but 2 took only English and biology. Very good. All right. Yeah, let's keep going. So PE and English. So here's PE and English. What goes here? 6, because it's 10 total. Same thing between PE and biology. That would be what here? 5, because it adds up to 9. Nice. All right, now we're just left with the exactly ones, the only PEs, the biology and English. So it says that 42 took English. So how do I figure out how many took only English? Yeah, 42 minus everything already in the English circle, or 12. 42 minus 12 is 30. Same thing for the biology. So it says 31 took biology, and I already have, looks like 11 counted for, so 20. Right. And then 13 for PE, because you have 28 total, subtract 15 for left with 13. Any questions on that process? Inside, working your way out. All right, but in A it says how many students took none of the 3 subjects. How do I figure that out? There's 100 total. How many is in all of? I guess how many is in all 3 of them? How do I add that up? What's that total? 80. 100 minus 80, I'm left with 20. Okay. Yeah, so whatever's left over goes outside. That's everybody else in your population. If they don't give you a total, well, then we can't do it. So 20. How many students took PE but not biology or English? 13. Right. It says PE but not biology or English. So you're not going to be in these circles. It means only PE. 13. What about how many students took biology and PE but not English? Biology and PE but not English. 5. So your little these little 3 things here, those represent the ones that do just 2 of the subjects, right? So 5. And guys, the biggest thing, man, people on the test, I'm telling you now, the one on the test is going to be like a three circle Venn diagram. And students get this part right all the time. It's just the questions they get wrong sometimes. The wording can be a little confusing. So just make sure you know exactly what it's asking, which piece it's asking. Questions on that one? All right, I got one more I want to do with you, and then we'll call it a day. Not this one. Not this one. This one. The other ones I'm skipping are pretty easy, pretty straightforward. This is the last type that you can have with Venn diagrams. So we can have one with 2, we can have one with 3. We can also have one that incorporates probability in it. Okay? And more specifically, conditional probability. Right? It turns out Venn diagrams are very helpful for bringing apart conditional probability. And we talked about this a little bit in the probability unit, but this is given statements like A given B, the probability that A occurs given B. What that looks like is probability of A. This little line here means given B. Okay. And what that formula equals, like how we find conditional probability with given statements, we talked about it kind of, but not really. It's the probability of both of them occurring, so the probability of A with the intersection of B, so like where they have that overlap, we can find that probability, and then usually divide by the total, but we divide by the given. So the given, in this case, the probability of B. That might be helpful to know. Okay? Probability of both divided by the probability of the given. Let's try it. If I ever give you one of these, it's not going to be too crazy. Something like this. He says we got a class that the probability of being a male is 0.3. The probability of having brown hair is 0.5. The probability of being both male and having brown hair is 0.2. Here's my information. My question is the probability of being female. Probability of being male given that I have brown hair, and the probability of being female given that I do not have brown hair. Okay? So, like I said, with any Venn diagram problem, we're going to ask ourselves, how many subjects do I have? How many circles am I going to have? Think carefully. 2, right? One's being a male. The other one is being brown hair, I guess. So the probability of being a male and brown hair. Yeah, you never want to put like the opposite of one of the circles as one of the subjects. Like if you have male, you won't have another circle being female because there's not going to have any intersection there. You can't have overlap between male and female. All right, and remember, you can also have probability outside the circle as well. Okay. It's an ugly, weird circle. Okay. But anyway, start inside like always and work yourself out. Now, I'm just curious. I'm not giving you a total here. What do you think the total is going to add up between all this? 100%. Or not percentage, it's probability. All right, in the middle. What's the probability of being both male and having brown hair? 0.2, I think. Okay. Both male and brown. And then work your way out. Now, it says the probability of being male is 0.3. So what's the probability of being only male with no brown hair? Right here in this circle. 0.1, right? The whole thing adds up to 0.3. The whole circle for male adds up to 0.3. What about for having brown hair right here without being a male, being a female? Wait, what? Yeah. Because the probability of brown hair has it at 0.5, so the whole circle adds up to 0.5. Now that's what, 0.6, how much is left over? Yeah. What does that 0.4 represent? Probability of being a female that does not have brown hair. Okay, so we got all the probabilities figured out. Question is this. Let's do the parts. 1, 2, okay, 3. First question says, what's the probability of being a female? How do I figure that out? Dude, what? Not me specifically, but what's the probability in this product? What? What's the probability of being male? How about that? 0.3. Yeah, the probability of being male is 0.3. So either you're male or female. So 0.3 is the 30% chance. So 1 minus 0.3 is 0.7. You got a 70% chance of being female in this problem. Oh well. But, alright, now here's the given ones, alright? So the probability of being a male given that you have brown hair. Given probability, you have to do the probability of both divided by the probability of the given. So you first got to figure out, I forgot what I was saying. Oh yeah, what's the probability of being both a male and having brown hair? Yeah, 0.2, it's right here. Probability of both is 0.2, so that's the top of my numerator. That's what I mean by that. And then divided by the probability of the given. My given statement is that I have brown hair. What's the probability of having brown hair in this problem? 0.5. Yeah, it's everything in the brown hair circle. 0.5. Probability of being a male, given I have brown hair. Probability of both, divided by the probability of the given. And 0.4. So 40% chance. This last one always kind of is fun. The probability of being a female given that we do not have brown hair. So first, I need to figure out the probability of both. What is the probability of being both female and not having brown hair? Female and not having brown hair. 0.4, right? Here's the probability of being male and having brown hair. Right there is 0.6. Outside the circle is the probability of being both female and not having brown hair. 0.4 is the given, or I'm sorry, is the intersection. 0.4. And then you want to divide by the probability of the given state, which is not having brown hair. What? Yeah. Probability of having brown hair is 0.5. So the probability of not having brown hair is also 0.5. I think that's like 0.8. Okay. Yay! Conditional probability. So those are the 3 types of problems you can see within the diagram. Make sure you know that all of them. That's some good probability. Let's end this bad boy with a smiley. Okay.